Okay, so this is going to be a 12 mark integration question. So, so we have a tangent that crosses to the x-axis at point O, and we have a curve, and we want to find this shaded region, which we can call R. So, we're given the equation of the curve, okay? Now, because this is an integration question, we might as well start off by integrating the equation of the curve. So, x squared integrates to 1 over 3 x cubed minus 3x minus 3 over 2 x squared and 18 to 18x. So that's our integrated equation for the curve. Now we're given the tangent to the curve at the point P meets the x-axis with the point coordinate 1, 0. So they're giving us 1. But we need the entire equation of the line. Now if we differentiated the curve and subbed in P, which we do not have, we would get the gradient and therefore solve for the equation of the line. So instead, what you would do is you would use these coordinates that you have right here and form an equation with the gradient in terms of m, and then simultaneously solve it with the equation of the curve to get what the gradient is at P. So we'll start doing that. So we have y minus y1, which is 0 because it's at x, equals m x minus 1. So y equals m x minus m. When you solve simultaneously with the equation of the curve, you have your final answer in terms of m, as you would do the discriminant to solve for m. So you would do that: x squared minus 3x plus 18 equals mx minus m. X squared, now bring everything to the left hand side, minus 3x minus mx plus 18 plus m. Now if we do b squared minus 4ac, we would have 1 for x. That would be a equals 1. We'd get b equals, if we factor out the x, we would get minus 3 minus m. And then c would be just these two, so 18 plus m plus m. Now, in an exam, on the right side, you would probably want to just write b squared minus 4ac to show what you did, just so that you don't lose out on any marks. So you would do minus 3 minus m. But as I don't have space, I'm just going to do it right here. Minus 3 minus m squared minus 4. Wait, what am I doing? Minus 4 times 1 times 18 plus m. So b squared minus 4, this is a and this is c. Now if I were to solve this, I would get 9 minus, oh sorry, not minus, plus, everything would be plus here, as if we did minus 3 minus m minus 3 minus m. All the negatives would cancel out, therefore the final equation would be positive. So you would have 9 plus 3m plus 3m, which would be plus 6m plus m squared. Okay, plus m squared minus 4 times 18, so it would be minus 4 times 18, which is minus 72, and then you would end off with minus 4m. Okay, now if I collect like terms, I get m squared cancel out. 6 minus 4 would be plus 2m. 9 minus 72 would be negative 63. Now, by doing so, you can use your equation solver on the calculator. Just to be safe once again, make sure you write the quadratic formula down on your paper. So I could do 1, 2, minus 63 on my equation solver, and I get two values. X is 7, sorry, not x. M is either 7 or M is minus 9. But as you can see, the gradient of this line is going upwards. If it was negative 9, the line would be sloping downwards like this. So we use that our gradient M is 7. That's how you solve for the gradient if you are not given the point P where the curve meets the tangent. Okay, so now we can finish off our entire equation now, because we have the gradient and two coordinates which we can fix the line with. So just get rid of all of this, and we can write down our equation. Okay, there we go. So we got m equals 7, so we'll do y minus 0 equals 7 x minus 1. So it become y equals 7x minus 7. So that's our equation of the line. Now, as you can see here, there's the easiest way of doing this would be integrating underneath the curve between 0 and p, which we can find out now. Integrating between 0 and p and finding the area of this triangle right here. Just like that. By doing that, we can subtract the entire area by the triangle in order just to remain with r in the end as our final answer. So if I begin now, we can find out what p is by solving for simultaneously with the equation of the line and the curve. So 7x minus 7 equals x squared minus 3x plus 18. And so if I put everything to one side, I would get x squared minus 10x. 18 plus 7 is 25. So I could put this into my equation solver and get 1 minus 10, 25. X equals to 5, and that's it. It's a repeated root, so not a repeated root. Yeah, it touches the curve and the line touch at one point, so it'd only be 5. So that's 5. So now I can sub 5 back in to the curve or the line to find out what the the height of where P is. So I could do 7 times 5, which is 35. 35 minus 7, which is 28. So this height right here would be 28. Now, to find the area of the triangle would be half 28 and 4, because this distance between 5 and 1 is 4. And that would give me 0.5 times 28 times by 4, which is 56. So we could write that triangle is 56 units squared. Now, we integrate between p and 0. So p is 5. And you can just do that right here. So we do 5 and 0. And then we can call this equation right here, sorry, this one, which is integrated, we can call it z, and just put everything into our calculator. So if I do that, I would get 1/3 5 cubed minus 3 over 2, 5 squared plus 18 times 5. And I would get the area between 0 and p, all of this right there, is 565 over 6. Subtract that from the 56 units that we got before for the triangle. If we subtract both of that, we should be left with r. So if I did 565 over 6 minus 56, my answer would be 229 over 6 units squared. That's my final answer.